All right, so we are moving on with 10.5, which is all about our rotations. Now keep in mind that we cannot complete the square here because there's an xy term. So essentially what we have to do is we have to determine the appropriate rotation formula to use so that we can get rid of the xy term so that we can have a formula that we can graph. Okay, so in order to do so, we're going to use some of the formulas that are on the other side. The first thing that we need to decide is what angle should we rotate this by so that the xy term cancels out. So instead of using cotangent, we're going to change this to tangent because I think you guys know tangent better than you know cotangent. But if I switch it from cotangent to tangent, then we have to flip this fraction. So then it would be b over a minus c. So that's the first thing we're going to use on the other side. So tangent of 2 theta equals b over a minus c. So that's our first step. Equals b, 18, over a minus c. So 1 minus 1. So that gives us tangent of 2 theta equals 18 over 0, which is undefined. Then to get rid of tangent on each side, we do tangent inverse. So that gives us 2 theta equals tangent inverse of undefined. Now we got to know our unit circle. I told you it never goes away. I know we haven't used it in a while, but here it is again. So tangent is undefined at 90 and 270, so we're going to use 90. So 2 theta equals 90 degrees, which means theta is 45 degrees. So that means that we need to rotate our axis 45 degrees in order for this xy term to go away, and then we could graph it. Right here, the problem was rotated 60 degrees so that the xy term canceled, and this is the equation we got. So this was rotated 60. In this problem, we want to rotate it 45 degrees. Okay, so now that we know the amount that it's going to rotate, now we need to figure out what is our equation. So flip again. Here are our equations. So x is equal to x prime cosine theta minus y prime sine theta, and then y is x prime sine y prime cosine. So x is going to equal x prime times cosine of theta, which is 45, that's what we just figured out, minus y prime sine of 45. And then y is equal to x prime sine of 45 plus y prime cosine of 45. Let me just double check. Yes, just making sure the formulas were right. So we know that unit circle cosine of 45 is root 2 over 2. So that's x prime times root 2 over 2 minus y prime times root 2 over 2. And then y here is x prime root 2 over 2 plus y prime root 2 over 2. So to make our lives a little easier, I'm actually going to factor out this root 2 over 2. And you'll see why in a little bit. So that gives us root 2 over 2 x prime minus y prime. And then here, we'll do the same thing. We'll factor out the root 2 over 2, which gives us x prime plus y prime. Okay, so these are our new equations, x and y. So now that we know what our new x are going to be and our new y is going to be, we're going to plug in our x and our y into this formula. And what's going to happen is when we go through and do all of our algebra, this xy is going to go away and we're going to be only left with x squareds and y squareds. Okay, so we're going to plug this in everywhere there's an x, and we're going to plug this in everywhere there's a y. So the first part of our equation is x squared. So x squared is going to be all of this squared. So 2 over 2 x prime minus y prime squared plus 18 times x, which is root 2 over 2 x prime minus y prime, times y, which is root 2 over 2 x prime plus y prime. So we did the x squared, the 18xy, now we've got y squared. So plus y squared would be root 2 over 2 x prime plus y prime squared. And then we're going to move the 2 to the other side, so we're going to add 2 to the other side. So equals 2. So here's our big long equation. So we have to be good at our algebra skills here. So when I square the square root of 2, that gives us 2. And then when I square 2, that gives us 4. So we have 2 over 4, which is really just a half. And then we're also squaring x prime minus y prime, which is x minus y times x minus y. Right, so that gives us x times x would be x squared, so x prime squared. Then x times negative y would be negative xy, so that'd be negative 2xy. And then we have negative y times negative y, which is positive y squared. So there's our first one. Now here, I'm not going to worry about the 18 quite yet. So we have root 2 times root 2, which is 2, and then 2 times 2, which is 4. So 2 over 4, once again, reduces to a half. Then we have this guy. So we have x times x prime, which will give us x squared prime, or prime squared. Doesn't matter how you want to write it. I'll go with my thing here. So x prime squared. Then we have x prime times y prime, which would be xy, and then negative xy, so those cancel, and then plus or minus y prime squared. Plus, now root 2 over 2 squared, we already figured out was a half, times, so this is x plus y times x plus y. So it'll be x times x, which is x squared, so x prime squared. X times y would give us 2xy, and then y times y will be y squared. Whew, so that's a lot of algebra. So that's why I told you guys 10.5 is kind of hard because of all of the algebra. Okay, so now we need to start distributing and combining like terms. So we're going to distribute this 1/2 in. So we have 1/2 x prime squared. 1/2 times negative 2 would be negative 1, so negative 1xy. And then 1/2 times y squared would be 1/2 y prime squared. Then we have 18 times a half, which is really just 9. So we're going to then distribute in the 9. So that gives us plus 9x prime squared minus 9y prime squared plus a half x prime squared plus a half times 2 would be 1. So x prime y prime, and a half y prime squared equals 2. Woo! So now that we've gotten all of our distributing done, we've done all of our algebra, now we can start combining like terms. So we've got 1/2 x prime squared, we've got 9x prime squared, and 1/2 x prime squared. So a half and a half makes 1, plus another 9 gives us 10x prime squared. Then we have negative xy plus xy, so those will cancel. Now, let's think about this for a second. The whole purpose of doing all of this crazy algebra is so that the xy goes away. So if this doesn't happen, you messed up and you need to go back and fix your algebra. Okay, so if this doesn't cross out, then your algebra got messed up somewhere and you need to go figure that out. That was the whole reason we did all of this crazy math. Okay, so then we got our y squared, so we got a half y minus 9, and then another half, so we've got 1 minus 9 will give us negative 8y prime squared, and then equals 2. Now remember that we are going to make this 1, so we're going to divide everything by 2. So that gives us 5x prime squared minus 4y prime squared equals 1. Now lastly, we don't want these numbers to be there, so it's going to be x prime squared over a 5th. That's the same because dividing by the 5th is the same as multiplying by 5. Minus y prime squared over a 4th, because dividing by a 4th is the same as multiplying by 4, equals 1. Now one way we can kind of also check our answer in a sense is we know this is a hyperbola, so let's use our skills from the last video. We know that if b squared minus 4ac is less than 0, then that means it's a hyperbola. So let's double check. So b was 18 minus 4 times 1. Oops, sorry, I messed up. It should be higher than 0. Times 1. Is that greater than 0? Well, that is greater than 0, so this is a hyperbola. That's a hyperbola. So we know something went right here. Okay, so for the last problem, we are actually not going to actually write the new equation. We're just going to figure out what equations we need to do so that the xy would go away, and we're going to stop there. So in order to do that, we first need to figure out the angle. So we have tangent of 2 theta equals b, which is -4, over a minus c, which is 1. So that gives us tangent of 2 theta equals -4 over 3. Well, I don't know if you guys remember, but there is nowhere on the unit circle that tangent is -4 over 3. So we have to do this lovely thing that we did back in chapter 7, where we have to draw our picture. So here's 2 theta. So tangent is y over x, so y over x, so the negative goes with the x here because we went to the left. This is a 3, 4, 5 triangle. Okay, so I need to figure out, because I need to use my x and y equations, and to find my x and y equations, I need to know what sine and cosine are. So we need to use, from chapter 7, our awesome formulas. So sine of theta is the square root of 1 minus cosine of 2 theta over 2. And cosine of theta is the square root of 1 plus cosine of theta over 2. So let me talk about what we need to know. These formulas, this guy, these two, you need to know those. You need to have that memorized. You need to know these on the test. You have to know those. Now these two I will give you on the test. Okay, I gave you the identity sheet on the chapter 7 test, so I would give you these as well because they're identities from chapter 7. So these will be given to you, but you need to know those other two equations. So let's figure out what sine and cosine is. So 1 minus cosine, well, cosine is -3 over 5. Subtract a negative would mean positive. So 1 would be 5 over 5. So that would give us 8/5. So 8/5 over 2, which would turn into 4/5, which would turn into 2 over root 5, which would turn into 2 root 5 over 5. Woo! So we finally got sine. Now let's do cosine. So cosine is 1 plus cosine, which this is 5 over 5 again. So that would become 2/5 over 2, which would become 1/5, which would become 1 over root 5, which would become root 5 over 5. So now that we've done all of that crazy math, now we can find our equations. So our equations, remember, is x equals x prime times cosine theta minus y prime sine theta, and y is x prime sine theta plus y prime cosine theta. Those are the formulas. These two you need to know. These two I will give you on the test. Need to know, give you on the test. So we know that cosine of theta is root 5 over 5. Sine of theta is 2 root 5 over 5. Sine of theta is 2 root 5 over 5. Oops. And cosine of theta is root 5 over 5. So for this problem, that's all I needed us to do. If the problem did say find the new equation, we would then plug these two into here and do all of the work that we did in number 3. But because this one has all this extra work, whenever I give you one like this, we're just going to stop at this point. So if I give you a problem where you can just find the angle, then I will ask you to go all of the way down. If I give you one that we have to use this, we're just going to stop here. That's long enough. All right.